Cool. I hope you're convinced that using linear regression for classification doesn't really help us that much. It creates complications that we do not want to deal with right now. So let's discuss a classification algorithm called logistic regression, which allows us to do classification in a much better way than linear regression. So the example that we're going to use here is going to be predicting. We're going to predict default on credit cards. So whether someone is going to default on their credit card payments, right? And defaulting on the credit card payments, it takes one of two values, right? It's either going to be a yes, the person is going to default, or no, they are not going to default, right? Yes, the person, well, when we're looking at historical data like we usually do with our training data, training data usually it's historical data, right? Because we already know who defaulted and who didn't. We're trying to look at their predictors to come up with a pattern to say, oh, these are the defaulters, these are the not defaulters, right? So we're saying, yes, these people defaulted, no, these people didn't default. And then when we do that, when we fit in our logistic regression, it's going to predict for new people when they come in. Should we give them a loan? Does this person fit a profile of people who default or not? So that is going to be our example that we'll use in this section, right? So logistic regression, it can be used to calculate the probability that y, that is logistic regression, that it calculates probability. It calculates probability that y belongs to a class, belongs to a particular class, right? Whatever class it's going to be belongs to a particular class. So here we'll calculate what is the probability of this person being in the yes class. What is the probability of this person being in the no class? That's what we're doing, right? So what we're basically saying here is the probability of default being equal to yes, given the let's say we're predicting default based on the predictor. Let's say the predictor that we're using is a person's balance in their account. What balance do they have on their credit card? We are going to predict whether they're going to default based on the balance that they have on their account, in their account. So here we're saying the probability of default equal to yes, probability based. So this straight line is just saying given or based on the person's balance. That's what we're doing here. That's what it means. This is what logistic regression is going to do. It's going to calculate the probability of default equal to yes, or the person defaulting based on their balance, right? As their probabilities, they will range from 0 to 1, right? So here we are going to use a notation. We're just going to abbreviate it to P balance. So this basically means probability of defaulting based on the balance. So this is it's just notation. It's just notation for it to be easy and quick to write, right? So a company might say, okay, cool. When you get your probabilities, people who have a probability greater than 0.5, we are going to call them defaulters. We are going to predict that they default. So which means we are going to predict that default is yes. Someone who has a probability less than 0.5, we are going to predict that the default is equal to no. And this comes after we've trained our logistic model. After we've trained our logistic model, then someone new comes, right? Someone new comes into our bank. And then we run the model on that person. And if the probability of default based on their balance is greater than 0.5, we'll say, this person is probably going to default, right? Or if their probability is less than 0.5, we'll say, yeah, this person will probably not default on their loan, right? Or even if it's existing customers that we haven't ran this model on them, we'll be like, oh, let's look at some people who are in another branch, right? In another branch, what are their probabilities of default? We run the model there. Then we might want to target the people that have been predicted to have a default of equal to yes. Try to try to intervene before they even default. So that could be our idea, right? Some companies are actually strict. Some companies will say, I don't want a 0.5. I want as soon as someone has a probability greater than 0.1, let's predict that they are going to default. So this is a parameter that you can tune, right? You might say, as soon as someone has a probability greater than 0.1, I want to be risk averse. I want to be conservative. So as soon as they have a probability greater than 0.1, they are in the default. Let's intervene before they get there. We are predicting they are going to default, so let's intervene before they get there, right? Less than 0.9, you'll be like, it's safe. It is safe, right? No. I think I'm saying this wrong. Not like less than 0. I don't know why I put that less than and stuff like that, because so here it will be less than 0.1. It's supposed to be less than 0.1. That is the safety net for you. That is the safety net for you for the probabilities, right? Otherwise, anyone else who has a probability greater than 0.1, they're going to default. Let's go talk to them, or let's go analyze and see how we can bring them back into good books, right? Before they get to be a bad client. So this one here is called the threshold. It's called the threshold, right? So the probability that marks the boundary between these two is called the threshold. So one thing I want to emphasize before we then get into the model itself, logistic regression is a binary model. Logistic regression is binary. Mostly it is binary, right? So it predicts probabilities. Let me say it predicts probabilities for only 2. It works very, very well in situations that have just binary outcomes. So seeing things like yes, no, only 2 outcomes. Logistic regression works very well. You can extend it to more, but many people in the industry, they use logistic regression in situations where they are binary outcomes. Yes, no, true, false, male, female, on, off. So things like on, off, right? On, off, up, down, left. Is it left? Is it right? Is it left? Is it right? Things like that. That's where logistic regression really performs well. So in our case, it will perform very well because our defaulting is going to either be a yes or a no. So binary. So this works very well. In the next video, we're going to get into the model itself, right? We're going to get into the model itself. So from here onwards, some things are going to get a bit technical. Even when we move from logistic regression to LDAs, they're going to get a bit technical. But I hope you bear with me and you'll be able to follow through. If you have any questions, you're free to just comment on the video so we can discuss further. But let's see what the model says in the next video.